an absolutely amazing star, this one. Theta 1 and Theta 2 Eridani, a double, brilliant white pair of stars. One is, you can see A43 and then A1V. So one's an ordinary main sequence star. The other one is already a giant. So it's on the stellar evolution scale, it's a bit older, getting bigger and bigger. Eventually, I don't know what's going to happen to it. But they're both a long period binary distance, 167 light years. Quite luminous, quite bright, but at a magnitude, the overall magnitude is 2.91. So they'll look bright. Be a wonderful thing to look at in the eyepiece. A is sort of moving away from blue, but still white, pure white. But it'd be interesting to look at through a telescope. So there's something to keep your eye on. There's a picture of it. I don't know why that picture's got a very the double star there, double binary. Now, another thing to look out for in the north, an interesting object. Last time when I spoke to you, you might remember, can you see that little fuzzy patch there? Can you all remember what that was? Can you remember from what I was talking? That is Brocchi's cluster. Remember the coat hanger? So if you want to look at something interesting, that little cluster right there. See that there? That's Brocchi's cluster. Anyway, so what have we got down here? Well, the first thing is this nebula, which I had never heard of or never seen. Has anyone imaged this nebula? Quite interesting. 6820 and 6823 is the blue cluster of stars. The nebula is very faint. You won't see much, but the star cluster is a lot brighter. I think this thing's about 12th or 13th magnitude, but the star cluster is much, much brighter.
Not easy to image it from here.
No,
because it's just a little bit above the horizon.
But you might see, that's right, these are low. So you might see the star cluster though quite clearly through it. I've never seen this cluster before, or looked at it. I don't know if anyone else has, but those pillars of creation are there just like you see in the Eagle Nebula and other nebulae. So, and there's another picture of it, quite a beautiful thing. That would be a challenge, Eugene.
Oh yeah.
That would be a challenge. It's quite attractive. The wide field view of it is really beautiful. Now this is the Dumbbell Nebula. Everyone's heard of the Dumbbell Nebula, M27, issue 27. I'm going to show you a little bit more about that in a moment. And down here, now, Lisa, imager of the Veil Nebula.
Yeah.
Lisa's taken some beautiful pictures of the Veil. You did the Eastern Veil, didn't you, Lisa? I think. Yeah. So there are two parts of the Veil Nebula, the Western Veil and the Eastern Veil, here right next to each other. Now, admittedly, low down, Cygnus is really dipping down.
That's
not a good thing to take pictures of, but I'd still like to look in this general direction. So, a close-up of, sometimes this is called the Apple Core Nebula. You know the Dumbbell Nebula is a planetary nebula, so it's a star that's expelled some of its material, and the star responsible is right in the middle, as you can see, right in the middle of there it is. It's got stuck in here. So the dumbbell, known as the Apple Core Nebula, in Vulpecula. Anyone know what Vulpecula is?
Fox.
Correct. I'm just testing.
You told us that last well.
Yeah, my mapping is good, Richard.
Sorry?
You said that last month.
We're just testing. I've got some more coming up in a minute, so I will be asking questions. Anyway, it's the same distance as the Orion Nebula, about 1,360 light years away. Visually bright, 7.5, diameter about 8 arc minutes, easily visible binoculars, and a popular...
Sorry.
That's all right.
That's the geographer.
Oh, you can see what's on the screen a bit better.
Oh, okay.
The TV screen was blowing out.
Oh, was it?
Yeah.
Anyway, so...
Just bear in mind that what's up there, what we're looking at, is a priority to what's up there.
Correct.
Yeah. Anyway, radius 2.8 light years, 9,800 years old, which is when the star exploded that caused the injection of gas. Yeah, so there you go, beautiful. I love the different, I don't know what, infrared, I don't know what the wavelengths were for that one, and using narrowband as well, a combination of images. Now looking from north to north, hang on, here we go. Now again, coming back to the Veil Nebula. This is the Western Veil, and Beautiful, sort of taken through different filters. Have you imaged this yet? Or?
I tried once, but from my phone it's really difficult because looking north, I'm looking over Aura.
Yeah.
And
So narrowband didn't help block out the light.
it did help, but
Yeah.
it was very low on the horizon.
Well, and there's the eastern veil on the right down the bottom there that Lisa's taken a lovely picture of, I remember seeing on Facebook. Eastern veil, the visible portions. Now there's one other bit though. When final results, some parts of the nebula appear to be rope-like filaments. The standard explanation is the shock waves from the supernova, which occurred maybe 20,000 years ago, are so thin that they're less than 1 part in 50,000th of the radius, so they're very fine filaments. So this takes a fair bit of exposure time. Anyway, an estimated distance of 2,400 light years. The nebula has a radius of 65 light years. The thickness of each filament, 1/50,000th of the radius, or about 4 billion miles. How is that all? 4 billion miles. Roughly the distance from Earth to Pluto. Undulations in the surface of the shell lead to these multiple filamentary images. Now if you look here, that's the whole nebula, the western veil and the eastern veil together, which is how they would appear. They actually appear, and the green line is the meridian, the north-south line. So they're straddling at this time, which is 8:30 p.m, 15th of October. That's where that position is there. Now, down the bottom, supernovas occurred maybe between 10 and 20,000 years ago that caused this. But down here, you'll see the sort of triangular shape. And I'll just bring up everything here. This is called Pickering's triangle. So you've got three components. You've got the western veil, the eastern veil, and Pickering's triangle, which is roughly a triangle, starting there and sort of going up. It's a beautiful looking thing. I love the wispiness. Quite an attractive object. Looking south, I've avoided all the old, the ones I've done before. This time I concentrated on Tucana. There's a beautiful sextuple star system up there. Have you looked at that, Steve? I know you would have probably looked at it and charted it. Beta 1, Beta 2, Beta 3, so they're binaries, all binaries. A lovely binocular pair separated by 27 arc seconds, the first two. And Beta 3 is a binary star separated from the others by 9 arc minutes, which puts the two systems at about 23 astronomical units, 23,000 times the distance between the Sun and the Earth. Or 0.37 light years. Bluish white stars, rather lovely. They look good through a telescope, Steve, yeah, very pretty. And so, a couple of pictures of them here. Now, down here, we haven't talked about the small Magellanic Cloud. I'm not going to dwell on it too long, but around it you'll see, hang on, that image is actually the wrong way around, by the way. I just noticed. Small Magellanic Cloud, dwarf galaxy. Now we have done the Large Magellanic Cloud because we did that before. A bridge of gas connects it to the Large Magellanic Cloud, the small one. People taking pictures of this, it doesn't seem to be very popular compared to the large one.
You need a long focal length because at 700 mil, the one I took, you can see something, but you really
Small.
need to dig in, yeah.
Yes, good point. So the small Magellanic forms a pair with a large one. They lie 20, which lies 20 degrees east. Now, the over to the right there is a globular cluster. We'll just come up here and we'll talk about those two things. Have a look at those two things there. Hang on. Next slide, we're almost near the end. The small Magellanic Cloud. Now, over here, up the top left, you've got 47 Tucanae, which is the second best. People always compete. 47 Tucanae, Omega Centauri, which is the better. Well, this one's got the bright heart in it, and it looks really, really fantastic through a telescope. So you can actually see a bright core. This is from Stellarium. So that's an actual, I think it's a Hubble image. Isn't that beautiful? It's a stunner, absolute stunner. And it's quite young as far as they go. 13 light years, 10 to 11 gig years. They're mostly 12 or 13 or 14 billion years, so this is a young globular. A beautiful object, and then 362 is the one on the other side. Sorry, oops. I didn't mean to.
I want to test your big data on this.
Sorry, there's 47 Tucana. The last image I showed you was 362, which is the one to the right. So if you turn it upside down, it's the image was upside
You
down.
can spot that red star.
Yeah, yes. So this is the gorgeous 47 Tuck. Isn't that wonderful? So you can see a very bright core. NGC 104 to those who dense central core, millions of stars, roughly the size of the full moon, 14,500 light years away, magnitude 4. Omega, I think, is about 3 point something. They're pretty similar in brightness to the naked eye anyway. And 120 light years across, which is not as big as Omega, which is 178 or something, or 180. Quite big. But a beautiful object. So there's something to keep in mind if you haven't been looking at that part of the night sky for a while. And finally, what is Grus?
Bruce.
Constellation Grus?
The crane.
The crane. Someone's got it good. The crane. I always said there are lots of animals. Lots of animals. There are 7, I think, bird constellations. Grus is one of them.
Around here.
Sorry?
A good number of them around there.
Yeah, Pavo, Grus, all sorts of things. Tucana, obviously the toucan. Anyway, up here there's a beautiful double star, Pi 1 and Pi 2 Grus. The genitive case, the second case of the noun, Latin noun is weird. Gruis, I would have thought it would have been Grus again, but it isn't, from my knowledge of Latin. I don't know why. Fine binocular pair, Pi 1 is an orange, red, irregular variable, and Pi 2 is brighter and yellow. Have you looked at that, Steve?
A couple of times, many times.
Yeah,
Yes.
yeah.
It's pretty so.
Very pretty, beautiful. As good as Alberio in Cygnus, or
Well, that's lower. We get a spoiled view of that because it's lower. This is nice and high and crisp.
because Alberio is yellow and blue, which is a lovely contrasting double in Cygnus.
Yeah, that's the one I looked at.
Sorry,
I looked at that a while back.
did you? Now, Mu 1 and Mu 2 Grus down here. If we can just get them down here. Here they are. This is a double-double. So you've got 2 doubles. But the interesting thing is, as Jim Kaler says, you get 2 for the price of 1. Oh, 2 for 1 special. Because in both cases, although they're not related to each other, the 2 binaries, they are exactly the same spectral classes and the same sizes. It's really weird. Yet they couldn't have formed together. They've got different relative motions. So they're not a pair, which is how they know they're not a true, it's not a quadruple system. That one's going up that way, this one's going down that way. I don't know where I got that from, I forgot. There's a picture of it. Very pretty, very orange. Both very orange. G3, one's a G8-3, sorry, that's a giant, but G8 is the spectral class. So they're very yellow. Orbital period of the 2 is 19 years. But they used astrometry and discovered there are smaller partners to each one. So they've got 4 stars really. I don't know what that galaxy is, but I'd love to. It's in the same field. So quite amazing. That's been taken by a very large telescope. Anyway, finally west. What's in west? One thing. Pan stars, still magnitude 6, disappearing very quickly if you want to get a look at it this month. It begins the month in Lupus, then in mid-month crosses into Scorpius, this is in October, and then back into Norma. So it's actually going, there's Norma, so it's kind of doing a loop. I think it's leaving. It's doing a loop, and I think it's going up that way. Probably go through Triangulum, Australia and all that. So it's on its way out.
I think it heads for Greece.
Yes, yep. So that's it. Now, last thing. Told you it was quick. One last thing. Our usual, and this is even shorter, I think. You get it? Right. Okay.
No, yep.
No music.
Oh, that's a shame.
What is wrong with this
Shut it
stupid?
down, shut it down.
Sing.
We cranked up the volume last time and they've turned it down again. Well, you missed all the dramatic music of 2001: A Space Odyssey. Just imagine it. Astronomy news of the month. Okay, so exciting things. Only 5 or 6 exciting things. Today, the DART mission reached its inevitable conclusion. and the satellite hit the. You remember you've got the two double asteroid redirection test, which is what DAR stands for. The big Didymus is the main one, and the one that it struck was Dimorphos, and which goes around it. And they struck Dimorphos at great speed, and there was a little. There's Dimorphos is a little circle there, and that was the first composite image. That was only a couple of days ago. So I wonder if they succeeded, because they haven't talked about the pictures. But with it, there was a cube satellite with cameras, and that was organised by the Italians, I think, and they organised a cube satellite to film the whole thing. This is amazing. This is like Hollywood out there.
So
they've got a movie camera moving along, taking. Oh, let's watch this collision. I mean, imagine to people 100 years ago, this would be unfathomable. So we're fortunate to live in such exciting times. Those cube things are tiny. They're only a foot square. They're not very big. Those little satellites.
30 centimetres.
30 centimetres, yeah, foot square. Yeah.
Those images will come out in the next few days.
Yeah. They'll be exciting. So watch out for images of this. And there's a picture of, this is the picture today of that thing just before it hit. And it's just pebbly. And one of the scientists, a view of Dimorphos, second before the dart impact, I think it was about 11 a.m. today, something like that. It's so cute.
Not anymore, it's not. Not anymore, it's not.
No, not anymore. Well, don't know. Anyway, I loved her description. It's so cute.
So I think it's about the size of the MCG, that asteroid or something.
Yeah.
The size of the
It's not. It's I forgot. I remember I did something about it last year, but it's not. It's not
curious
very big.
about the composition, because that is not a plain rock. That
No.
looks like it's a mass of boulders and the
Yes.
dust held together. Yeah.
Yep.
So maybe it just went through.
Yeah. Oh, huge satellite. This made me sick to the pit of my stomach. Look at that thing. That's going to shine in the night sky, and they're going to put up a whole lot more. Look at the size of it. It'll collect light. And they reckon, astronomers are going mad about it. Look, it's going to be above the Earth. All they're doing is, let's test the 4G, 5G capacity of this thing. We'll put it up and see whether it can send signals to remote areas. So a new scientist was talking about it. Anyway, the CEO of this company said, size is everything. He's a Texan.
Oh, okay.
So that explains it. He actually said, size is everything. So look at the size of this thing. Anyway, the astronomers are concerned that a planned constellation of more than 100 of these are going to be put up there. The Blue Walker, they're called the Blue Walker satellites, and the Falcon X rocket. I had a picture here of the Falcon X taking off, but I thought, no, I won't leave that. I'd rather put in this quotation here. As it points to constellation, the operational satellites, which would be named Bluebirds, junk birds, could cause even more interference, as they are expected to be of similar size to that one. Astronomers have expressed concern, which is a polite way of saying they're really fed up, over the brightness as it joins the hordes of commercial satellite constellations currently being built in low Earth orbit. From the location of Rubin Observatory on Cerro Pachon in Chile. Some scientists there were...
It should be fine, because 80% of the US population lives in the northern hemisphere, so they will be flying up there.
Yeah. And we'll be going, no, we'll still see the Starlink one.
Don't care what they put above Texas.
Yeah, that's right.
Relates to the warming of the planet.
Now, look at this spellbinding new image. Have you seen anything like that? Look at that. Now that's a Wolf-Rayet star. Remember we talked about an O-class star, which is a very system. That's a graphic of the system. A high elliptical orbit of 7.9 years. That's a James Webb telescope image to get that kind of resolution. Visually a moderately bright Wolf-Rayet. Well, that's a bit of a joke. I mean, Wolf-Rayet stars are 40, 50,000 degrees Kelvin. They're very hot. So moderately bright within the spectroscopic binary, a star around 5,600 years away, located in a triangle between Deneb and where we're looking at Cygnus, Gamma, and I. So it's right in the middle. Okay. I had a look at it, but I couldn't see it. It appears on the Stellaria. It's in there. But boy, can be seen in the animation of it. The dust is a form of carbon, which absorbs ultraviolet light from the two stars. This heats the dust, causing it to re-emit thermal radiation, which is how it's been observed by Webb, because that's an infrared telescope. Sorry?
And that's how Webb sees it.
Yeah, it's as infrared. So, wow, what an image though. I mean, boy, that wasn't possible before. We're near the end now, folks. New web image captures clearest view of Neptune's ring in decades. You've seen this. This has been in isn't that amazing? I just love that. And that, what's that bright object? Triton. And the reason Triton is so bright is, there's an explanation here. Most striking is Webb's image of the planet's rings. NASA's Voyager 2 became the first one to take a picture of them back in 1989. In addition to several bright narrow rings, the Webb image clearly shows Neptune's fainter dust bands. Webb's stable and precise image quality permits these various faint rings to be detected so close. Now, covered in frozen sheets of condensed nitrogen, Triton reflects a lot of light, which is why it's brighter to start with than the actual planet. 70% of it. And it far outshines Neptune in this image because the planet's atmosphere is darkened by methane absorption. So normally you wouldn't see that difference, but because the planet absorbs methane, it's not as bright.
The other cool thing in the background, there's a wider field. This is a cropped part of the image.
Yeah.
That bit's cropped.
Yeah.
But if you look at the full image, you'll see several galaxies, including a nice spiral in the background.
Oh, wow.
And there's one off to the left there.
Ah. Anyway, yeah. Oh. And then I didn't realise Triton has a retrograde orbit. So it goes east-west instead of west-east, which is interesting. And that's, I think, oh, that's it. Oh, this is beautiful. The one of Hubble's recently. Hubble's still giving. You know, it's an amazing telescope, I think. Look at that stunning image of that. NGC 1961, 200, twice the size of the Milky Way, an intermediate spiral. It's just beautiful. In Camelopardalis, which we can't see because it's below the horizon. It's above 50 degrees north latitude, I think, or something. Declination. We can't see it. What a shame. Look at it. That's one thing they've got to watch. In fact, Bigby was invited to submit he submitted images, I think, when they were doing, before they did the judging. So, Gerald Riemann. I reckon technically it's brilliant too, because the comet's moving. And he's got still stars and the comet moving. So the tracking for that object would be astonishingly difficult, I would imagine, especially at this magnification, because it doesn't look like it's been blown up a lot. So he's probably, that's very tricky. And the spikes indicate some sort of reflector. I don't know. Interesting. The Royal Museum's Greenwich Astronomy Photography Year. It blew the judges away, apparently.
It's definitely a fast scope, because you can't do such a thing with a slow one.
No.
You get
Well, that's right.
in such,
Yeah, look at the detail in it. And the reason they loved it is because it's a breakaway bit.
Yes.
They got the what's it called, a disconnection event.
Yeah.
So the material broke away. So that's really bad.
Bruce Willis has been there and he's smashed it up.
Yeah, Bruce Willis. Yeah, sorry.
What is on the left side of the image, what is the bright blue right in front of the...
That's the coma. I think that's the coma of the comet.
Yeah, that's the coma.
So it's heated up and blows a little bubble of gas around.
Yeah. It's not going to put
Dust
pressure
gets
on it.
pushed off that and
Yeah.
makes the tails.
Yeah.
But it also, the dust and the gas gets ionised and connects with the magnetic field. And so when the magnetic field of the sun changes with the solar wind going by, you can distort the tail.
Oh, you would think if he saw a picture like this of the things he was looking for, and he could never really see. You know, I mean, he saw comets, but not like this.
Richard, how long would that disconnection event last for?
I don't know. I mean, a distance of I don't know how many hundreds of millions of kilometres away it is, but that would be. It would leave it behind, wouldn't it? It'd be a trail.
It would move down the tail. And you get there's a series of images showing it moving down the tail as you go.
And eventually it'd just dissipate, wouldn't it? And become material that causes...
And that tail went out on that scale, out over there.
Yeah.
And they followed it out.
And eventually, the bonus is we might get some showers, chunks of comet, causing a meteor shower or two.
Tinfoil now.
Sorry?
Buy your tinfoil.
Tinfoil. Okay, thanks folks.
Yeah.
Yeah, I'm sorry. We finished on time if nothing else.